You've seen from the General College physics materials, excuse me, I get choked up when I talk about that course, how the ideal gas law arises from the kinetic theory, and I'm not going to go over that here. I'm not going to add anything to what I've already done there. So that when n is constant, the PV over T quantity is constant. So we have PV1 over T1 equals P2V2 over T2. And again, PV over T is constant. Now that's a good approximation. It works just fine as long as we don't need a great deal of precision. However, we can correct for it because a couple of things the derivation of PV equals nRT left out is the fact that some of the particles in a gas might be attracted to each other. That's going to have an effect on energies and momenta and all kinds of things, and that's going to have an effect on the relationships between pressure and volume and temperature. Another thing that we have to take account of is the fact that these molecules actually take up some of the space in a gas, and the derivation that we have does not account for that. Now, without going into a great deal of detail, let's discuss the van der Waals correction. Okay, the van der Waals correction pretty much says PV equals nRT. You have these small terms here that we use to correct for things like attractions and volume occupied by molecules. Okay, we have a correction AN squared over V squared here, where N is the number of moles and V is the volume of the substance. And this is really a correction for volume. This kind of represents the, well, this actually represents the proportion of the volume that's occupied by the molecules themselves. And A is just a constant that we determined by experiment. Then we have this NB here, which is number of moles times B, and actually, let me take back what I said, this is a correction for the volume occupied by the molecules. It's proportional to the number of molecules. Okay? So we're going to subtract that proportion from the volume. Okay, this is a correction for the forces exerted by the molecules. I said that, wasn't really thinking. I saw V, thought V. It's late. Sorry. And this goes back to the fact that the closer the molecules are together, which means the more N per unit of volume, the more strongly they're going to be attracted. And of course, that attraction is pretty much an inverse square law, so that we're going to square the N over V ratio. Again, A and B are terms that A represents how strongly the molecules are attracted as they get closer to each other, and B represents how much volume each molecule occupies. And these are things that we have to determine by some fairly sophisticated experiments that we're not going to discuss. Okay, so we see that this van der Waals correction is much like PV equals nRT, but it's corrected for the attractions and volumes of the molecules. And we do experiments, and then we do some curve fitting to determine the values of A and B.